All right, we got ourselves some story problems here that we're going to do some logarithms with. So let's just kind of dive in. Sorry, I got them numbered backwards here, but the first one we're going to do is number 2, and then we'll jump to number 1, but we're going to start with this one. In 2015, the world population was around this many billion people. Then in 2020, it was this many billion people. You can see it grew. Find the rate of growth for the world's population, round to the nearest hundredth of a percent. We're just going to kind of say that population growth is a continuous situation, like it just happens continually. So we're going to start with our formula, which will be PERT. So we'll write that down, and then we'll sub in what we know. The principal is how much it started with. Well, you know, the starting value is our lesser year. Like we got a year 2015, year 2020, so our 7.379 is going to go in for the principal. That means the amount that we had later at an ending date is the 7.94, and then E, of course, is involved, and then our rate, we don't know. That's what they're asking us to find, but we do know that from 2015 to 2020, that's been 5 years. So the thing we're missing is R. And to solve for R, we're going to have to use logarithms since R is up in the exponent, and we've got to get that to come down to Chinatown. Before we can do that, we've got to get this base all by itself on one side of the equal sign. Since there's a times 7.379, we're going to go ahead and divide. And yes, I know they were both in billions, but since they're in the same unit, we're cool there. So we're going to divide both sides. And you know what? I punched that in the old calculator. It came out nasty. So to leave it exact, I'm just going to leave it as a fraction like that. So, cool. Now we're ready to log both sides so we can get that exponent to come down in front because we got that base all by itself. And being as how that E is involved, we are going to a natural log both sides. So we'll have the natural log of Weirdo McGee right here, and exponent comes down in front, and then you get yourself the natural log of E, which that's a beautiful number. Natural log of E is really 1, so we can just kind of strike that out. And then the final move is to divide both sides by 5. So what we're going to do is I'm going to punch this guy in my calculator, if I get it to drag over. I am going to do the natural log of, remember it starts at parentheses, 7.794 divided by 7.379. Close up my parentheses. I'm going to hit equals also. And this is the number that I just have to divide by 5 to figure out what R equals, and there we go. R is this small little guy right here, just so you can see. So remember, they say round it to the nearest tenth of a percent. So it turned out to be 0.0109-ish, but I need to write 4 places down because to change him back to a percent, I got to move this decimal 2 places, and that means it's about 1.09% is what the rate actually was. So as a decimal, I needed 4 decimal places. Since they wanted 100th of a percent, you need your 2 decimal places plus 2 more decimal places. So that's kind of tricky. Speaking of tricky, let's try this one about Yolanda's grandma. You left her some money. Nice. Yolanda put that money, which was $6,500, into an account that earned this much interest compounded, monthly. How long will it take for that money to triple? So the formula we're going to need is the compound interest formula from a while back. We don't get to use PERT because they didn't say continuously, they said monthly. Well, for Yolanda to triple her money, we don't actually get told that, but we got to take the 6,500 times 3 to realize, oh yeah, bro, to triple her money, that'd be 19,500. So substituting in, you get the 19,500 for the amount she wants when she's all said and done. The principal was the 6,500. Then we sub in 1 plus is in the formula. The rate, of course, you got to change it to that decimal by moving that 2 places to the left. Number of times you earn interest is 12 because it's a monthly situation, and then times the 12 times t power. Well, beans is how we're trying to solve for t, and t is up in the exponent. Logs will be involved, but remember you can't log both sides until you get this base all by itself. Even though the base is messy, like we're not going to punch him in and round him off. We're going to leave him this exact number right here. I got to get rid of this times 6,500 first. So I'll divide both sides by 6,500, and ta-da! It turned out to be 3. Of course it turned out to be 3 because we were trying to triple their money. That's how we found this number. So that's cool. And now that we've got this base, even though it's in parentheses, we're just going to take a blind eye to parentheses. We've got this base all by itself. We can log both sides. We don't really need the natural log because e is not involved, so I'm going to bring the log to both sides of the common log, and Mr. Exponent came down in front. Look at this giant mess over here now. You've got all of this, but see, it's all being multiplied together. Remember again, I'm going to use red. We just don't get to see what's in parentheses, but all of this stuff is being multiplied together. So to get t all by itself, we are going to divide both sides by it. So what a mess. We've got the log of 3, which was over there already, divided by the 12 had to be down in the denominator. The log of this number had to be down in the denominator. And this is the exact answer. So to punch that in, wow, is this messy. If you think you can punch it from top to bottom, you can. It's quite a mess to do it that way with parentheses. So what I do is I just kind of start with the mess. I'm going to do this whole denominator first, one piece at a time. I'm going to start inside the parentheses and do the 0.058 divided by 12 and hit equals. And that'll get me this little highlighted deal. What I got to do next is add 1 to it. So, okay, so I'll add 1 to it. Cool. And now I've got the whole number that's in the parentheses in my calculator. What needs to happen to that number is it needs to get logged, right? So I'm going to do the log of my previous answer. We're not rounding that guy off or anything like that. I got to use the previous answer button. So I got the log of that. Cool. That's a weird tiny little guy. But what still has to happen to that is a times 12. So, okay, times 12. And this is the entire denominator now, this tiny little guy. I need the log of 3 divided by that guy. So log of 3, don't forget to close your parenthesis, divided by my previous answer. And whoo, there she goes. It says round to the nearest tenth of a year. Well, 18.98 is going to actually round up to about 19.0. So that's what I got. Time was about 19.0 years. That was a mess to type into calculator. If you need help punching that in, please come ask. We will help you punch that in. But we're going to keep on keeping on into this next dude about carbon-14. Carbon-14, I got a story here for you of like how carbon-14 actually works if you're into science and stuff like that. So it explains how the carbon-14 process really works. But it's a way that the scientists have figured out to be able to tell how old something is. So here's the formula that they use also. Got all kinds of crazy variables. They say where A is the initial amount of carbon-14, so when somebody dies, they measure the carbon-14 in it. T is the number of years ago the animal lived, and Y is the remaining aftermath of T years. How old is a fossil that has lost 95% of its carbon-14? So, all right, let's slow down again. What's A? A is the initial amount of carbon-14. Well, that's the tricky part. What you got to realize is that the initial amount of carbon-14 have when you die is 100%. You've got all of it, 100%. So 100% goes in here, but we can't put a percent into the formula, so we've got to put a 1 in. So we're going to put a 1 in for A. So here's what I got going on so far. I got a 1 in for A. There's an E in the formula. I got the negative 0.00012, then times T. So that's what we're solving for. So that means that we have to know this Y value, which is like how much carbon-14 you currently have. And they super try to trick us on this one because they say, dude, they have lost 95% of their carbon-14. I don't care how much they've lost. I care how much they've kept. So if you've lost 95%, haven't you kept 5%? That's the number that needs to go right here. As a decimal, you have to have kept 5%. So we're going to put all of that in. And wow, excuse me. Wow, that was really weird. So it started with 100% of its carbon-14, and it's lost 95%. Don't care how much is lost. Got to care how much it's kept. Once we get to this point, though, when we get the numbers in the right place, it's money to solve this guy. T's up in the exponent, so we're going to log both sides. Since e's involved, we're going to natural log both sides. So, all right, got the natural log, and that brings Mr. Exponent down in front. And having a 1 here really doesn't do us anything, so that's sweet. That 1 can just kind of disappear because it's 1 times all this. And here you get the natural log of e. That's a beautiful thing. That's 1 also, so that totally disappears. To solve for t, all that's going on now that he's down on the normal level is there's this times negative 0.000112. I'm going to divide both sides by that guy, and then we'll just punch that guy in. The natural log of 0.05, close that parenthesis, divided by negative 0.00012. And they say round to the nearest year in this problem, so don't be afraid that you get a really big number here because they're talking about fossils, and yes, fossils can be very, very, very old. So that was about 24,964 years old. So, whew, that was a very weird problem. How about this? At the end of an advertising campaign, the daily sales of a product fell rapidly, with the daily sales given by this equation. So here's the equation for their daily sales in dollars. X is the number of days since they ended the campaign. So an advertising campaign is, hey, yo, we got something for sale. Let's say it's an iPhone 14. iPhone 14 for sale. iPhone 14 for sale. They're selling it. They put money into this campaign. And then all of a sudden they decided to stop putting money into it. And X is how many days since they stopped putting money into that. So what were the daily sales when the campaign ended? That means X equals 0. Because when the campaign ended, it has been 0 days since the campaign has ended. So if I put 0 in for X, well, that's actually going to be so easy I can do that without a calculator. So putting 0 in for X, I'd get negative 0.08 times 0, which is 0, right? So the exponent turned out to be 0. I got to do e to the 0th power. Cool. Well, anything to the 0th power is 1. And then I got to take that times 3,200. So 3,200 is the initial amount right there. That's how much sales they made that day after they stopped advertising. How many days have passed since the campaign has ended before the sales were below half of what they were at when they ended the campaign? Well, when they ended the campaign, they were at 3,200. I want to know when they get halfway, so I got to do half of 3,200, which is 1,600. So I want to figure out how long does it take for the sales to get to 1,600. Cool. Well, 1,600 goes into S, and the rest of the formula is still there. And now we're going to solve for X. Since X is up in the exponent, we want to get him down to Chinatown by logging both sides, but we can't log both sides until you get the base all by itself. So I need to divide by 3,200, and ta-da! It's a half, right? They wanted to know when we were at half as much, so there we go. And now we'll natural log both sides, and by natural logging both sides, Mr. Exponent came down in front. And natural log of e is there. That's a beautiful thing because that's 1. And to solve, I just need to divide by negative 0.08. So I need the natural log of 1/2, which you can put as 0.5 if you want to, or you can do 1/2, divided by negative, is it 0.08 or 0.8? It's 0.08, right? So nice. Divided by negative 0.08. And ba-ba-boom. It took about 8.7 is what X turns out to be. So X is about 8.7. But they asked how many days did it take? So it's not 8.7 days. We got to round that to 9 days. You know, it's like, all right, that took about 9 days if I can get my screen back. So that's what we're doing. X is about 9 days. About 9 days. Boom. During a period of constant inflation, the value of a $100,000 property is going to increase by this equation, by 3% is what that says right there. Started at $100,000 because that's the price of the property, going up by 3%. How many years will the value of this building? How many years will it take for the value of the building to double? So we'll substitute in, and by subbing in, this is a PERT situation, kind of, sort of, maybe. And by substituting in, I guess we didn't really need that since they gave us the formula already. But it started at 100,000. We want it to double, so go to 200,000. And we got to get this all by itself first before we can get the exponent to come down to Chinatown with logarithms. So we got to divide by the 100,000. And that, of course, turns out to be 2 because that's what we were trying to do, was double our money. That's how we figured this out. And now we can natural log both sides by, and that'll bring our exponent down to Chinatown. Natural log of e is 1. To solve for t, we're going to divide by 0.03. And natural log of 2 divided by 0.03. And your test is going to ask you for the exact answers. So this is the exact answer right here, the natural log of 2 divided by 0.03. So when they say give an exact answer, that's this, natural log of 2 divided by 0.03. Sorry, for some reason I hit my zoom button. And then when they say give an approximate answer, that would be this, about 23.1 years is what that took. So exact, boom, approximate, boom. This one makes way more sense to us though, but I don't know. They like the exact answer also. And finally, Steve predicts that he will need 80 grand for his new daughter's college tuition. Steve found a bank that offers this much continuous interest. How much money should Steve invest now for his daughter to have 80 grand in 18 years? So continuous is a PERT situation. Noise. The question is the 80 grand the principal, the original starting amount, or the amount he wants when he's all done? Yep, you're right. It's the amount they want when they're all done. So we'll sub that in. We know the rate. We got to change them to the decimal, though, of course. And we know the time. We don't know the principal. They say, how much should Steve invest now? And check it out. Here's my question. Do I need logarithms for this? The answer is no, because the variable we're looking for is already down on the normal level. It's not up in the exponent. So what I am going to do is clean that up. I'm going to take 0.08 times 18, and thank you, calculator. I got 0.864 for that. And now to get p all by itself, there's this times e to the 0.864. I'm going to divide both sides by e to the 0.864. Punching that guy in the calculator, 80 grand, 1, 2, 3, divided by e to the 0.864. I think that was the right number. 0.864. Sure was. And by punching that in, you get this old boy. And we'll round that to 83 cents. We'll round her up. So $33,717.83 is how much Steve has to put away now if his bank's going to give us this kind of interest for him to have 80 grand in 18 years. So cool. Those were some story problems. I went through them fast, but you have a pause button so you could pause things. Please come see us for help on things you did not quite understand. Have a good one.